Hello everyone, welcome to NPTEL Chemistry E-class. I am Chemistry Detective to solve your Chemistry class 12th NCERT problem from Unit 1, that is solutions. So our problem is a solution of glucose in water is labeled as 10% by mass. Find molality of solution, mole fraction of both components, molarity of solution if density of solution is 1.2 gram per ml. So we have a solution and we will try to first identify its type. It is solution of glucose in water. Glucose is solid, water is liquid. So our solution is solid in liquid solution, or I may say our solution is liquid solution because phase is determined by solvent. As solvent is liquid and that too water, so it is an aqueous solution and it has only two components, glucose as solute which we will represent by 2 and water as solvent which we will represent by 1. Any parameter related with solvent water we will represent it by 1 and any parameter related with solute glucose we will represent it by 2. Now given is mass percentage of this solution and given is density of solution. From mass percentage of solution and from density of solution, parameters known to me are mass of solute which is equal to 10 grams, mass of solvent which is equal to 90 grams, total mass of solution which is equal to 100 grams, because mass percentage of solution is 10%, which means 10 grams of solute glucose are present in 100 grams of solution. So mass of solute glucose is 10 gram and mass of solvent water is 90 gram, total mass of solution is 100 gram. And we know density is equal to mass by volume. Mass of solution is 100 gram, density of solution is given. So if I apply formula of density, second known parameter to me is volume of solution, because volume of solution will be equal to mass of solution and by density of solution. Both mass and density of are known, so volume of solution is known to me. Now problem is based on concepts like molality of solution, mole fraction of solute and mole fraction of solvent and molarity of solution. First one molality, second mole fraction, third molarity. All three are units or methods of expressing concentration of solution. However, they differ in amount of solute and solvent. I mean they differ how we express amount of solutes, amount of solvent and amount of solution. Otherwise they are all methods or units of expressing concentration of solution. And you might be knowing that molality is number of moles of solute present in 1 kg of solvent, 1000 grams of solvent. Mole fraction of solute is ratio of number of moles of solute and number of moles of solution. Mole fraction of solvent is ratio of number of moles of solvent and total number of moles present in solution. And at last molarity is number of moles of solute present in 1 liter of solution. Idea is that I need exact equations of molality, mole fraction and molarity that are related with given mass of solute, given mass of solvent, molar mass of solute, molar mass of solvent and volume of solution. And the actual equations are and the actual equations are: number 1, for molality. Molality is represented by small m and is related with molar given mass of solute W2 multiplied by 1000 molar mass of solute M2 multiplied by total weight of solution expressed in grams. Weight of solution expressed in grams. And molarity, I may determine, in order to determine molarity, I will substitute values of known parameters. Mass, available mass of solute glucose is 10 multiplied by 1000. Molar mass of solute glucose is 180. Molecular mass of glucose is 180 and mass of solution is 100. Now molality of solution comes equal to, we need to solve RHS side of this equation, and exact value of molality comes equal to 0.67 moles per kg of solvent. Here it is essential that you got idea why I took given mass of solute W2 equal to 10 grams and why I took given mass of solution equal to 100 grams. Because in question given is mass percentage of solute, mass given in question is mass percentage of solution, which is 10%, and it means 10 grams of solute glucose are present in 100 grams of solution. So weight of solvent will be 100 minus 10, which is 90 gram. And molar mass of glucose C6H12O6 is 180, which you can calculate by adding atomic mass of 6 carbon, 12 hydrogen and 6 oxygens. Simple substitution of known parameters in this equation, by simple substitution of known parameters in this equation, I was able to find molality of solution, which is 0.67 mole per kg. Now what is information here? Information is that if we have 1 kg of solution, it contains 0.6 moles of solute glucose. If we have 1000 grams of solution, it contains 0.6 moles of solute glucose. Now second equation is that mole fraction of solute is calculated by this formula. Mole fraction of solute is equal to ratio of moles of solute N2 and total moles in solution. Since solution is binary, only 2 components, total moles in solution will be number of moles of solvent 1 and number of moles of solute 2. Now I will express number of moles in terms of available mass and molar mass. I know number of moles is the ratio of given mass of solute and molar mass of solute M2. Similarly, for N1, I will express N1 in terms of given mass and molar mass W1 divided by M1 plus number of moles of solute again W2 divided by M2. Now what are these parameters? W2 is given mass of solute, M2 is molar mass of solute glucose, known to me 10 gram and 180 gram. W1 is mass of solvent 90 gram, M1 is molar mass of solvent water 18 grams. Here again I will substitute values of these known parameters. mole fraction of solute chi2 will be equal to W2 is weight of solute is 10 divided by molar mass of solute is 180, weight of solvent is 90, molar mass of solvent water is 18 plus 10 divided by 180. I now need to evaluate the RHS side of this equation, and after evaluation I got that mole fraction of solute here is 0.01. This is mole fraction of solute in this solution. Fraction of moles of solute in this solution are 0.01. You have to consider that total number of moles in solution are 1. Now out of this 1, 0.01 moles are constituted by solute. Now I can easily calculate mole fraction of solvent, because I know mole fraction of solute and sum of mole fraction of solute and solvent in binary solution is equal to 1. So mole fraction of solvent chi1 will be equal to 1 minus chi2. 1 minus 0.01, it will come equal to 0.99 mole fraction of solvent. Now what is information? Information is that if fraction of moles of solvent present in this solution are 0.99, if total number of moles are 1, out of this 1, 0.99 fraction is constituted by solvent water. It is a sort of dilute solution. Now third equation I need is equation of molarity, and the exact equation is molarity is equal to W2 multiplied by 1000 divided by M2 multiplied by volume of solution but in ml. W2 is known to me, M2 is known to me. I have to first find volume of solution in ml. Volume of solution in ml will be equal to mass of solution by density of solution. Mass of solution is given 100, density of solution is also given 1.2, and it comes equal to, and volume of solution in ml comes equal to 80, it comes equal to 83.33 ml. Now I need to substitute this volume in this equation in order to find molarity. Molarity will be equal to W2, which is 10 multiplied by 1000, molar mass of solute glucose is 180 again, multiplied by volume of solution, which is 83.33, and after on evaluating RHS side of this equation, molarity of solution comes equal to 0.67. moles per liter. Now what is the information? Information is that this solution has 0.67 moles of solute present in its 1 liter. 1 liter of solution or 1000 ml of solution or 1 decimeter cube of this solution has 0.67 moles of solute glucose. Molality, if I may correct, molality is equal to 0.617. Molality of solution of glucose in water is 0.617, mole fraction of solute is 0.01, mole fraction of solvent is 0.99 and molality of solution is 0.67. Information is 1 kg of solvent has 0.61 moles of solute, fraction of moles of solute are 0.01, fraction of moles of solvent are 0.99. Total number of sum of mole fractions of solute and solvent is 1. Molality is 0.67 and information is that 1 liter of solution has 0.67 moles of solute glucose. Thank you. See you day after tomorrow, because tomorrow is reserved for class 11.